Good afternoon, all. So, hope I'm audible and my screen is visible. Okay, so before I proceed uh, for my class, so let me just show you the last session. So we had just demonstrated, right? So small thing, which is an application, demo application for just to have a greeting card, right? How does it look like, right? So as it said, so this is a hierarchy of the folder. So which you can see here, you'll have three files. One is manifest folder, okay, and then you'll have a programming file wherein that you'll be having an application called as ui.theme main activity.kt. It depends on the language which you choose during the application when you're starting up. Okay. Avira. Okay. Uh, 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 mhm. Okay. Good. ಸರಿ ಬಿಡು ಸರಿ ಬಿಡು ನಾನು ಆಮೇಲೆ ಮಾಡ್ತೀನಿ ಕ್ಲಾಸ್ ಇದೆ ಒಂದು ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಮಾತಾಡ್ತೀನಿ ಓಕೆ ವೆರಿ ಗುಡ್ ಕಂಗ್ರಾಟ್ಸ್ sorry. So you'll have this hierarchy where in that application, so you'll have one of the thing where I said there will be three things will be there in that any activity, any application you create. One is the manifest file. Okay, so that always the default file will be there, which is going to call as Android manifest.xml. So this is a bridge between your application and your system. Okay, so please remember that. So that will be default. We can edit, but there is a default content will be there in that which is not editable. Please remember this. Okay, so that's a default content will be there in that application, so that we cannot have any option to edit those things. We can edit, but we should not delete anything, which is a minimum requirement. So this particular line which you're seeing, this is the only thing which I have added extra here. Okay, so other than that, so there's nothing to be added here, which are all of them are default. As it said in the previous application, it is clearly said. So there should be a launching activity. So what is that launching activity, right? So this will say dot main activity, right? So this is said to be the main activity, and the name of that is main activity, and that is set to be the launcher act. That means when you open application, what screen it should be appearing onto you. So that is what it is all about. Okay, so this will be there. So we will discuss more on this and later on. Okay, and then this is your logic where using that application, what and all you wanted to demonstrate, right? So maybe a simple calculator. So in the calculator, what will be there? There'll be a text box which is visible to you, and there'll be a buttons, right? So there'll be a C, that is clear button. When you clear the text, it should be clear. So like that, this entire thing which is there, which you are assuming that's a logic which you want to write. Or by clicking that button, what should happen? When you click equals, what should happen? When you click only the number, what should happen? So I'm just thinking on that. I'm ready to write all those things over here, which is a main logic we're going to write here, right? So this is the main activity.kt. So that means for any application, you'll it is not necessary that there will be only one activity. You cannot have only one activity. Maybe for a calculator, yes, only one activity. But when you say example, I just want to have an application for a university, so or maybe for a college or something like. So you just need to have for everyone there'll be user login activity. So that will be one screen. After that, home screen will be there. So there'll be a navigations. So each of these navigations, when you go across, and it is called as one activity. Okay, each of them is called as one activity. right? So this is the entire thing, and there'll be a resources, right? So there will be a drawable, so where all these things XML files are there, we'll not do anything over there. There'll be a manipulations, okay, and then you'll have values, colors, if you want to change the colors of them. Okay, so we'll have this, these are all the colors which you can use in it, where if you want to change some of them particularly, so you can change them. There'll be a strings, right? So that the application name, what it should appear onto you. So demo application I've given, so that you want to change it to something else, so that you can straight away you can do that here. And themes which you can there, which is default, it is there, so you can keep it. If you want to change, you can do that. But most of the time we will never touch these things, which is not much of the important for us, right? So we don't touch them. So we will be working mainly on this and then here. Okay, so this is so, and then let's remove all these things which is not necessary for us, right? So let's see main activity and XML activity, right? Now how that, so what is there in the main activity? So you'll have a, there will be packages which just gets imported. So defaultly, just right now we don't want any package explicitly be to be installed. Okay, so right, so you have an application super.on create. That means we have seen the life cycle of an activity. When you create, what will happen? So it is creating an application or activity. So on create saved instance state. Okay, so what is the thing which you have to do on this content? Set the content on this application theme. So greeting card is a thing which is the, what is the name? Android. The name of the greeting card is Android. Okay, and then so modifier dot padding, so that I'm just padding, that padding values is equal to inner padding, so that should not touch the borders, right? So and then so there'll be a text which is to be displayed on that. Okay, so greeting is a function, fun is a function, greeting, and it takes a string as an input, and then modifier is equal to modifier, so that's going to pass it over there. So hi, my name is, okay, so my name is, so which dollar name. Okay, so that name wherever I'm going to spell on the preview, right? This is a function of the preview. So where I'm going to say name is equal to this. So this will be passed over here. Okay, whatever you specify here, that will go as it is over there. Okay, right? See, whatever the changes would automatically appear here, right? So we can have, but ultimately this has to be viewed on the screen of a demo. The thing is, we have to run that. Okay, right now we are just not doing that because we have to. If you run that, it will take a lot of time. Possibly, device manager. I'll go here and set up medium phone, which is Android 16. So if you run this, okay, so it is asking me to install that hypervisor. It'll take time, so definitely it will take extra time on this to complete it. Okay, so let's hope that will be done. So let us just not, okay, Android is up to date, running Android emulator hypervisor installer. Okay, this has to be not been restarted. Okay, 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 so it's not working and there's a problem. Okay, and store Android emulator hypervisor. I don't know. So it's failing. Okay, so that control service failed. Okay, so let me just check it. What I can do, I'll just we'll just see that what we can do right now. Let's not worry about that. Let's go ahead and change the. So to go to the, let's go to the content. All right, so okay, so today user interface design we're going to talk about. So this contact session will be talking about this Android UI design, introducing the layouts as well as fragments. So this is a record lecture content you're supposed to go. So in the previous session, so system Android is system driven, so not no single main will be there. Okay, so then Android manifest.xml tells with the Android. So we'll have identity, name, icon, theme, permissions, which you can give for any external thing to be accessed. You have to give the permissions, so which may be internet or camera or anything. So the launch rules will be activities will be there, plus the intent filters where we're going to set that this is a launching activity. Life cycle is OS control, so it can be paused, it can be stopped, it can be destroyed, created, anything can be. So what is Android UI? So every Android application, so when you build, so that you'll have the way of interaction. So that way of interaction to be more user friendly. So that is what mainly we just you prioritize. So when you look at the application, so that I should not be confused what to access, how do we access. So the accessing should be very easy for us. So that means your application should have a more user the easy way of communication, right? So that should be main objective behind your user interface. So built for the users, it's not about the code. So users will not see how it is working, but it is only thing is that they will see how I'm feeling when I'm using it. Okay, so you can see there are a lot of screens will be there, the buttons, lists, and navigations, many things will be there. So it is all about how what to be visible on your screen, right? And how do I interact with it, right? How the navigations are taking place. That means the screens are getting connected to each other. Okay, so before we write them, so we must understand how the users experience the application, right? So the common UI elements will be like there'll be a text messages, right? So which is going to be appear. So there'll be buttons. So maybe say example, I just want to have a login. So where the login, you enter the username with the text field, and you enter the password with the text field. And when you have a button, you just say OK. So that means it should authenticate and give the message, right? So you'll have a login button or submit button, or it could be anything else. So there'll be a set of images which is visible on the screen. Okay, so and then you'll have a lot of the list of contents which is visible onto the screen. So the actions are like you're going to have, like most of the devices are touch screen, right? So you'll be touching on the screen to perform the app. So you'll be tapping, or you will be scrolling down, or you'll be swiping it. So or navigating between the screens. So where you can see that there's a lot of things which you see on the real-time examples. If you look at the Android, right? So you say example YouTube. When you click a particular video that will play, right? There'll be a set of videos which will be given in the form of a list where you have to scroll down. Okay, so things like that. It just use a right navigation from left to right. If you use that application will go back to the previous state, right? So there's a way to interact, and the things will gives you or makes you life more easier. So the most applications are made of these made with the multiple screens, right, which are connected to each other. So among them, all the screens will be there. One screen will be made as a main screen where it is going to be appearing as a starting screen, and uh, there could be have some screens to give or depict some messages or the meanings for them. Okay. See some of the examples here, which is shown here, right? So WhatsApp, right? So when you go that when you open the WhatsApp screen, you will see that all the chats, right? List will be there. When you click a particular chat, it will open the entire chat screen for you, where what are the communications happened there. So Amazon have open home will be there. If you click a particular product, it will go to the particular product details will be there. There will be a checkout. So it goes on with one by one, right? So YouTube also, you will have home screen where you will see all of them are listed accordingly. You will swipe up, swipe. You will have option for swiping up or down, right? And then double tap on the particular video so that will play, right? So you can scroll down. You will see the comments. So like that. So the top level view is the main screen. Whenever you see the first the applications get started. Okay, so it will shows you the primary choices or maybe the different categories. So example, in a music streaming application such as Spotify or YouTube or Ghana, wherever. So the top level view might show recommended playlists for you, a top charts, right? And the recently played songs will be there. It's the starting point for the users to explore the application. So you can just have a look at this diagrams, which is right. So the detail view, right? So it just gives you this first point, which just gives you this is a product, right? So when you double click that, it will open the another window where another screen will get appear, gives you more details on that. Okay, so the detail view is a specific screen where users can see more in-depth information about that product. Okay, so in e-commerce applications like Amazon or Flipkart or eBay or wherever the things were, or Mintra, wherever it is. So if you tap up on a product, so it will be going to the next screen or the next activity, giving more information about that product, with giving you a different set of images about explaining about them, or it could be giving you the details about them, the specifications about them, the usage about them, the feedbacks, kind of those things, right? So that gives you more information to understand about the product. A standard components, so are the basic building blocks that may every applications, most of the applications will be using them, like the buttons or the text boxes or the sliders. So that will give you a more feel familiar, and at the same time they will also makes you life easier. So in a food delivery applications like Swiggy, the standard components include the add to cart button, so search bar, rating, and the delivery icons and text fields for addresses and promo codes. So standard components of the UI, the Android AR, so is built using a small set of core components. What are those? There'll be view groups, activity, and the fragment. Okay, so this the view is a traditional UI which is represents the one UI element. Example, what could be whatever it is, one UI element only on the screen. It is just not the entire screen or an activity. So maybe just a text box, or it could be a text message, or it could be a button. Anything else, all of them are said to be one. So view group is a set of components together, holds and arranges them in the order which you can view them in a better way, right? So activity. So that's all these view groups are organized on a screen, which is called as an activity. Okay, so used in both, which is the case of XML also as well as Jetpack Compose also. And then you'll have a fragment, so it represents part of the screen, so which is would be tabs or reusable sections or multi-screen layouts. Okay, so may still act as a host or content. So what is a fragment? So Android UI is what users see, touch, and interact with on the screen. Okay, so the you can set up a screen with a particular dimension, what to be appearing on that application or an activity. So say example M into N widget or a favorite widgets where you can see. So that gives you the things like that you can organize them in a better manner. So as I mentioned, so that anatomy of the Android UI is that there'll be views, there'll be view groups and the layouts. Okay. So full screen arrangements, view groups is a linear or constraint layout. View is only a particular entity of that UI. So the basic UI elements, so of course this shows the content, right? So accept the input, right? In the view, individual UI element, it could be any of them. Like as it mentioned, text, it could be image or it could be a string, anything. Everything you touch on the screen is a view. So between these two, view versus the view group. So Android UI is built using two core building blocks. One is view, a single UI element. The other one is view group, a container that holds and arranges the views. So the hierarchy is that it will have a view. So that view could be image view, or it could be a text view, or it could be view group. So the text view will also have a button. So that is part of your text view. The view group where it will be organized all these views in order. It could be linear, or it could be frame, or it could be hierarchical, anything as such, right? So which parent, right? View group is a parent, view is a child UI element. So constraint layout, so view group, so contains text view, button, image views, and many things as such. So this is one simple thing, like which going to have a text view. So the things which has been said, wrap the content and wrap the content for a width and height to match that things. And the text is welcomes to bits belonging. And the text size is 18 SP. And the color can be set as 00. That's a black. So you change that number, automatically the color will also change. And there's a button, right? So the button btn submit, right? So button name of the button is button submit. So btn submit is a name. So content to be visible on the text is submit. Okay. So we just have these things, right? So which a view group is a special view that holds other views and controls their placement. Okay, so let's say I just wanted to have this on the new screen which I create. Okay, so let it start. By the time will just see what things are. So I'll just started a new application there. A view group is a special view that holds other views and as well as managing them. Okay, so the main job is that add the child views for them, arrange and make them placed on a particular order, right? So that the examples for them is recycler view, okay, or a scroll view, or a content or the linear layouts. So layouts in the views, right? So will is a type of view group. That means how it is organized. It could be linear or vertical or horizontal, or it could be hierarchical. A layout is a type of view group, so which is particularly used to arrange views on the screen. So example, linear layout, row or column, or relative layout, which is positioning relative to others. Right? Constraint layout, so flexible and modern positioning. So root layout, linear layout is always so it is automatically it will be there. So we need to set up them. If you want to change, you can change it. Okay. So linear layout, so which will be there. So this is the entire screen will be organized in that way. A text view is a view, so used to display text to this user. So username, and edit text is a view text, so which is going to be given, enter the username, and width is match parent. Button is a view, so used to perform an action when clicked, right? So a button will be created, right? So how layouts control the size of this? So every UI element, what you need on your screen, right? So which has two things to decide, or two questions will be there, which is going to be decided. How wide should it be, right? How tall should it be? Okay. So there is a parent. Okay. So where you say you want entire thing to be adjusted according to your parent screen. So then match parent will be used, right? So only required space, that means a particular way or this only in that position I need to organize. So then go for wrap content. Okay, so two important size rules will be there. One is a match parent, where it takes all possible space. Wrap content takes only the required space for that text to be appearing on. Okay, so traditional Android. So where you're going to have the layout, match parent, wrap content, so vertical text view, username, and the login, right? So same layout idea. So different syntax. So you're going to have a Jetpack compose. A column modifier is equal to modifier.fill max width. Text is equal to text is equal to username. Button on click. So modifier is equal to modifier.fill max width. So text of login. So that will show. Fill max match parent. So default size same as wrap content. Width is same as like. Spacing inside of versus outside a view. Okay. U elements are need U elements need space. Otherwise, screens lock crowded. So that means you have to organize them such a way that there should be a proper spacing, and then they are organized a, such as it should appear like a grid, so that it will be easy to organize, and it should not be oversized with each other and things like. There are two types of spacing. One is a padding, the other one is a margin. Padding is a space, that means on the UI element how much space you want to be organized. Margin is how this image or how this element has to fit according to the dimension of your screen, the entire space. Okay, so we can organize. Padding pushes content inward, margin pushes views away from each other. So how spacing is defined? So Android padding, so Android layout margin, so XML code which you can write. Text is equal to submit. uh, Layout is equal to width to wrap content, so height is equal to wrap content. 16 dp is a padding. And then so if you want to do them on a compose, right? So using modifier.padding, so compose example, so button on click of this modifier is equal to modifier.padding with a 16 dp. Text of that will be equal to submit. Okay. So Jetpack compose is an Android modern way to build user interfaces using only Kotlin code instead of designing screens on XML and writing logic in Kotlin. So we'll be doing them together using a compose, right? So in Jetpack Compose, you describe what the screen should look like. And Android takes care of drawing and updating it. You write US UI like instructions. Show a welcome message. Place a button below it. When the button is clicked, do something. Okay, so that we're just writing like a English. We're just telling them orally to a person, right? Similar to that, we are trying to communicate to the system. So building UI with the Jetpack Compose. So in Jetpack Compose, an Android screen is built by combining small UI functions, which is written using Kotlin language. So UI is created using a composable functions. No separate XML layout files are required here. UI structure and behavior live in the same place. So we need to write them separately. So in Compose, a screen is just a Kotlin code that describes the UI. Okay, so where a welcome with button. So column modifier is equal to modifier dot fill max size dot padding of 16 dp. So horizontal alignment is equal to alignment dot center horizontally. Text is equal to welcome to Bits Pilani. So font size is 20 sp. Color is color black. Spacer modifier is equal to modifier dot height, which is 16 dp, and button on click. So text submit. So this code shows a welcome message, a button below it, both centered and stacked vertically. So the composable marks this function as a UI function. So every compose screen is built using composable functions. Composable means this function which can perform the drawing for you as UI. So column arranges items vertically, similar to linear layout. So in an XML. So modifier, so it is used to specify the size or how much spacing, what is a padding, right, inward or outward. So in this code, so fill max size, so uses the full screen of this the activity. Padding will define the space from the edges, how much should be removed. Okay, so text is a function. So welcome. So we got to define display text on the screen, and size of them is specified. Font size is being specified, and color can be defined for that. Spacer modifier is equal to modifier.height 16 dp. So what it does, adds empty space, pushes components apart. So button, a text will be given for that. It says submit, and on click, so nothing to be done right now, so just submit, right? So what it creates a clickable button. On click defines what happens when what happens when clicked. Okay, so submit is the name of the button or label which is going to be appearing on the screen. So Jetpack Compose, we are going to build the UI screens using this. So to show text on the screen, so we use the text composable function greeting text. Text is equal to welcome to bits Pilani. Font size is equal to 20.sp. Color is equal to color.black. So this is for image. Okay, so show logo image where the painter is equal to painter resources, which has been referred through the ID r.double.robot. So content description is equal to app logo. So modifier is modify size, which you can specify. So for submit button, so on click, so action when button is clicked. Modifier is fill max width, and the text is submit. So combining UI elements into a screen. So individual UI elements become useful when we combine them inside a layout. Simple screen. The column modifier is equal to modifier.padding. So text is welcome to sdpd. Spacer modifier is .height. Button on click this. So this will become more. So there's a set of modern concepts which are there in Jetpack. So state and remember. So state is the data which we have already entered. Say, just to make you understand about this, let's say you're just filling an online application. So there are so many fields are there which you have to fill, and multiple pages. So you have done maybe there are 4 pages. Let's assume screens are there. You've done 2.5 page entries are done. So the remaining 1.5 page you have to do. Suddenly, which will close the application. Now, if it is restarted, you have to redo the everything. So that will be very, very challenging. There. Can it be possible to remember what I have entered so that it can, when the application starts, so that I can automatically fill those data already entered? Remaining can be continued data. Okay, state is the data that can change while the application is running. In Compose, we remember to store a state inside a composable. Example, so where count by remember, so mutable state of. Okay, so what this means is the count the stores as a value. A compose remembers it's across recompositions when what you entered earlier. So when count changes, the UI will also get updated. Recomposition, so that means which will the UI is going to redraw the things automatically when state changes. You do not manually update the UI, so where we go to just go for it, key change the data with UI updates automatically. Preview lets you see the UI without running the application. Example, show background is equal to true. Where composable, the preview home will be there, and you just call a home screen method. Okay, so live example, counter button. So counter example, so state a value that can change where count by remember, so mutable state of 0, where the UI will show you the current value. So button on click is not equal to count plus plus. So what's happening here? Count is a variable, it's a state variable. It keeps the value, right? So which what you have already there. So it remembers them. When it gets updated, that will just rewrite that and it's going to update to the person or a variable to remember what is the previous value. When the button is clicked, count increases and the compose automatically reads the text over. So there'll be no find by view ID, no set text, or no invalidate. So where user interface is nothing but a set of functions with a given set of states. So from the UI state to a real application, so where what we did till now is to understand about the Jetpack Compose, build using them, and store data using remember, and UI updated automatically using recomposition. So what are the important questions which UI update automatically using recomposition? So what happens when the application becomes bigger? So there'll be a set of screens. It is just not with can be done with a minimal number of screens. So that will be more number of activities will be there. So that means you'll have more screens, right? And more data to be managed. And application can rotate, pause as well as restart, and sometimes it can hang also. So remember is a great for learning, right? UI, but real applications need stronger structure also. When the UI should not hold important data. So what Android can do, the system here, stop the application at any point of time, recreate the screens, kill and restart the activities. What this means, so UI can disappear, so UI can be recreated. UI should only display data, but not have the ownership on that. So golden rule is that the UI shows data, but they never have any authority on the data. That means they are not the owners of the data. If UI should not own the data, so then who? Data must live outside the UI. Right? So that means your data should not be residing inside the application, should be outside of your application or outside of your UI. So UI should only display data and react to the changes. So another component must store and manage the data more safely. So simple mapping. So UI with will have compose or the activity. So where it's going to shows more of the data. Stakeholder. So where it can be done through the Android system can recreate any UI anytime. So in real applications, so the important data is kept in view model. So state which is going to survive screens recreation better. And there could be a repository or the data layer, so where it can be stored through APIs or the databases. And the database is one of them, which is going to store very safely and permanently. Who manages your data? So in real applications, data is handled by the stakeholder, so that uh, the application owner or something we can call it as. Okay, a data source, which is the API or the database. What UI does is it's going to just reads your data from the source where you specify and displays them on the screen wherever it is necessary. Right? So the other thing is that sends the very clear user actions towards the upward. What UI does not do, so which not store the data, store important data. It won't do that. It won't directly fetch the data until you give instruction, and it also doesn't remember the or make decision on the business data. So this is to understand more about us, which is link for it. Now let us go and understand what is a fragments. So fragment is part of the screen. So it is used to build the modern UI things. Okay, a fragment always runs inside an activity. A screen can have one or more fragments. A simple way to remember that activity is equal to full screen, right? Fragment is a section which gives you what to be done inside this screen. So why we use the fragments? Fragments will help us to split your screen based on your necessary, so that it can organize the data in a different dimensions of it. Okay, split a large screen into a smaller UI parts and then reuse the same UI section in different places where as and when it is required. Design flexible screens for different device sizes also. So important note for that. Today we only learn what a fragment is. So we are not going to life cycle or advanced fragment code now, because that's very important to understand. We have that in the later sections. Right? So the large screen, a small UI screen. So how does it look like, the fragment UI, organizing them on the screen, right? So which is fragment. So in Jetpack Compose, most application will user interface can be built using composable functions. So you usually don't need fragments just to create and reuse the user interface. The Compose will encourage us the building screens as small modular functions. So the application data, the UI data, right? So can be built using the composable functions using Jetpack. So you usually don't need the fragments just to create those or to make it useful or reuse them the UI. Okay. So the compose will encourage us the building screens as small modular UI functions. So which can include the UI at the same time the logic behind the screen. Okay, or which is related to that, and also can be reused anywhere in the application. So can adapt to different screen sizes with the help of Kotlin code. So instead of multiple XML layout folder, so it will just organize them properly. So the activities or fragments may still be used as hosts or containers in some application when how the applications are older or fixed mixed projects. But in modern ways, so we just don't use them. So we just go with the frag, while the compose handles the actual UI. So the Android UI is about what users see and interact with, not just a code. The screen is built using UI elements, so arranged by layouts. In traditional Android, UI was created using views, view groups, and XML layouts. In modern Android, Jetpack Compose lets you build UI using Kotlin code only. Okay, so Compose UI is made of small composable functions that can describe what the screen should look like, automatically update when the data is changed. Okay, so UI should only display the data, but they never own the data or import the data or anything, managing them also. Android system can recreate the screens anytime. So UI must stay simple and reactive. So that's it from my end for today's session. So hope what is required. So I think we have just covered it as of now. Let us see some way to demonstrate these UI. How do we create it?
Basics. With this new playlist, I want to focus on explaining the core Android concepts which are purely used for native development. And this is also not only targeted towards beginners, but also if you're already familiar with some Android development, that is also for you, since all these basic Android concepts, such as activities, the backstack, and all these kinds of things are often only scratched on the surface, but it definitely makes sense to go into these a bit deeper. So this playlist is not intended to make you an Android developer from nothing, but rather for those people who are new to the Android ecosystem or just want to deepen their knowledge. But on the one hand, it assumes that you know Kotlin, the programming language we use for native Android development, and I also won't cover any UI building here because for that I have my separate Jetpack Compose playlist. In this playlist, I will talk about things like activities, the lifecycle, the backstack, broadcast receiver, services, intents, all these Android specific things. What I will leave out though are concepts that don't find application nowadays due to Jetpack Compose. So for example, fragments is a topic where I have an older video about, but I decided to not make a video about that in this playlist because most new Android apps nowadays just don't use that anymore due to Jetpack Compose. And in this first video, I want to talk about activities and their lifecycle. So whenever you create a new Android Studio project, then you will end up with something like this. You will have a class main activity, which is in this case a component activity, and Android Studio will generate an onCreate function, which you override here with some initial content, in this case with Jetpack Compose. We want to ignore this Jetpack Compose stuff here completely and focus on this outer thing, this activity, and what that actually is. An activity itself is kind of a container for one or multiple screens in your app. But that's only part of the truth. I wouldn't only see it as a container for screens, but rather as a unit of your app where your users interact with. And that is also why activities are called activities and not something like screen container. So this activity will contain information about if it's currently active on the screen, if it's in the background. It will also serve as an entry point for your app. So that means if a user comes to your app from another app, for example, your browser, if they click on a link or so which opens your app, then an activity is a component that directly gets launched from that action. And in the past, we usually did it that way, that we had one activity per screen. Then things changed a bit and we got fragments. So we often bundled the different related screens into one activity. So you might have one profile activity with a normal profile screen, a profile edit screen. So multiple screens are just bundled into one activity, which hosts these different screens. And then nowadays we got Jetpack Compose, which usually means we will only have a single activity in our whole app. So in this case, with the Jetpack Compose setup here, we can have lots of screens, as many as we want, while staying in the single main activity. So in pure Jetpack Compose projects, this main activity will just serve as the entry point for our application. So if another component, another app, for example, a system component, needs to launch our app, then it needs to directly say, I want to launch this activity, or I want to just launch this app, and this is the starting activity of that. But the main characteristic of activities in Android is the so-called lifecycle. So that means at some point our activity is born, so it's called created, and that is what this onCreate function stands for. And at some point it's not needed anymore, all its memory resources are freed up and it's destroyed. And in between there are just some steps that happen which move this activity into different so-called lifecycle states. And if you just take a look at the official activity lifecycle diagram from the Android documentation, we get to see this picture. This is the whole lifecycle. Looks super complex, but let's break it down because once you understand it, it's actually fairly simple. As we already saw, once the activity is created, onCreate is called, so it will move into the created lifecycle state, and that is just the place where we want to initialize our variables inside of that activity, where we want to set the actual view, so the actual UI content of that activity, and just do some further setup and initialization. At this point, the user does not see anything on the screen yet. After the created state, it will start to move into the started state. So onStart will be called when that is complete. An activity is considered to be started when it becomes visible for the user. But at this point, the user still can't interact with it yet. So you can kind of compare this with a theater where the curtains open up initially and you can already see all the actors and everything from the play, but the play itself is not starting yet. However, after the started state, it will move into the resumed state. When an activity is in the resumed state, that means it's in the foreground, the user can interact with it, and that's also where it will stay until the user eventually moves away. So you can see here, the activity is running in this case, so it will block the state until something is happening. And as you can see, as soon as another activity comes into the foreground, the lifecycle state will move to on pause. And this is actually a bit inaccurate because it's not only moving to the pause state when another activity comes into the foreground, but when any different piece of UI comes into the foreground, for example, a dialog, which doesn't need to be an activity. So at this point, all the resources the activity needs will still be kept in memory because the user might still come back to the activity, which is very likely if they see a dialog or so, where they just need to apply some kind of action. But it could also be that they just navigate to different screen of their app where they might decide to click the back button and come back to the previous activity. And if that happens, so if the actual activity which is in the pause state comes back into the foreground, then you can see when the user returns to the activity, the lifecycle will move back to the resumed state. So it's in the foreground just as before, and it will stay there until the user moves away again. But how do we now get from on pause to on stop? You can see the activity is no longer visible, but isn't this the same as moving away? Well, if the user navigates from one activity to another activity, then on stop will also be called and the lifecycle state will move to the stop state. So what's then the difference between the stop state and the pause state? If an activity is in the stop state, you can be sure that it's not visible to the user anymore. If it's in the pause state, it could still be that the user is seeing a dialog and the actual activity that is paused is still somehow in the background. So you can imagine just like on your desktop PC, where you have different windows, so different activities, and your browser might be in the background and you might have a smaller window in the foreground, which is your focus. So in that case, the browser, which is in the background and not focused, would be in the pause state, while the smaller window that is in the foreground is in the resume state, since it has the user's focus. But as soon as the whole window is not visible anymore, it would be considered stopped. So that would be the case if the user navigates to another screen, since then only that new screen is visible on the screen and not the previous screen anymore. If the user then comes back when the activity is in the stopped state, you can see then on restart is called, which is kind of a special function when the user comes back to an app that was minimized before and that was hidden. So this just gives you another callback to react to exactly this kind of use case. And after that, on start will be called again, so the activity will be made visible to the user, and then on resume, where the user can finally interact with it again. But last but not least, as you saw, we also have on destroy. So what does need to happen that our activity really gets destroyed and all its resources get freed up? So this diagram says the activity is finishing or being destroyed by the system. What does finishing really mean? So usually that either means that you either intentionally closed it with the finish function inside of an activity, or the user is currently on that activity and is active, and then they click the back button, because that tells the Android system, hey, I don't want to be active on this activity anymore. Please take me to the previous one. So
create PDF spaces in a click. Connect your docs and the dots. Unlock insights and next steps. It's easier than ever. Adobe Acrobat.
If you are feeling like you are just struggling under the weight of everything that's on your plate, then my course, Time Management Mastery, Do More, Stress Less, is your next step to having the time you need. In just 2 hours, you'll learn how to manage your workload, how to make effective prioritization decisions, and how to feel good about your time every single day. Hi, I'm Alexis Hasselberger. Join me on Udemy.
the current activity is not needed anymore and it will be destroyed. Or obviously, as this description here says, if the system, so the actual Android operating system, needs memory and it might decide to kill your app, then on destroy will also be invoked. There's also another special case in which the lifecycle will reach the destroyed state, and that are so-called configuration changes. That means when some kind of global configuration changes. The most common example is a screen rotation. So when the user rotates the device, that means the layout the activity is showing also needs to be re-inflated. It again needs to be loaded from the resources maybe, maybe there's a specific landscape layout. So everything will be set up from the very beginning again. And in that case, the whole activity will be recreated and the lifecycle will start from on create again as soon as the device is in landscape mode then. That doesn't only happen with screen rotations, but also, for example, when switching the language of the device and many more. But I don't want to go that deep into these configuration changes in this video. I will talk about that in another one, but they come with more problems than you might think at first. And if we now take a look back here in code, then for all of these lifecycle states, we have a function inside of an activity we can override to react to these. So if we take a look here, we can also override on start, which is called as soon as the activity becomes visible, as I said. So here we could simply print something, let's say on start. After on start, we would call on resume, which is called as soon as the user can interact with the activity. So here we say print line on resume. We want to have one for on pause, print line on pause. And let's have one for on stop, print line on stop, one for destroy. Here we want to print something. And what is missing? We're missing on restart, which is called when the user comes back to the app which was previously in the background. So here we say print line on restart. And let's also add such a log in on create, since we're missing that right now. And if we then change this to on create and launch this app on our emulator, and then also take a look in logcat to see our logs, let's just filter for these parentheses, or better, we replace this with system out. So now we see all these functions that get called, and that is exactly what you just saw from the diagram I showed you. Initially on create is called, when that is done on start is called, and when that is done, so when the activity is visible to the user, then the lifecycle state will move in on resume. And if we take a look here on our emulator, this is currently an active activity. We see the screen, we see this hello Android text, so the user is currently interacting with the app. And that is why the state stays in resumed. If we now move away, so we minimize the app, for example, completely minimize it, then you will see on pause and on stop is called. On pause because it moves into the background, and on stop because it completely gets invisible to the user. And as you can see, that is the case. The user does not see anything of the activity anymore, and it's not just seeing a dialog or so where the activity is still in the background. And if we then get back to the activity right here, then you can see on restart is called, start, and resume. So that is exactly what I showed you here. After on stop, user comes back to the activity, on restart is called, on start is called, on resume is called, and that is where it will stay again until the user does something, moves away, or closes the app. Let's also quickly take a look at that when the user closes the app by just swiping it away. Then you will see on pause is called, on stop is called, and on destroy is called. So then the activity is really destroyed. All the resources, all the UI is freed up. It's not kept in memory anymore. And to get it back on the screen, we would need to create a new one. There are certain cases where on stop and on destroy might not be called. So the Android system does not guarantee that these are always called. So if you have some very important data to save, for example, before the user leaves the app, I would always do that in on pause. But other than that, that is how activities and the lifecycle works. If you enjoyed this video, then definitely leave a subscribe and don't miss the next Android basic videos. You'll get 2 new videos here every single week, Wednesday and Sunday. So definitely stay tuned. I wish you an amazing rest of your week, and I'll see you back in the next video. Bye bye.
Ever wondered how apps like Google Pay and PhonePe are built? Our new masterclass on the low-level design of payment apps breaks it down step by step. Learn how to